Hello, everyone. Let me give you a short introduction about Apiumhub. We are doing this event in collaboration with Dynatrace and the JUG. And yes, just a little short intro about us. Apiumhub is a software development hub. We are based here in Barcelona. And our goal is build a goal-driven working software. We are working, following the best practices for different clients, trying to improve every day. And actually, we are a software consultancy, but the good one. So then if someone wants more info about us, come in and let's have a chat, and thanks for coming.
Okay, so hello, thank you everybody for coming. I guess English is okay for all of you? Yeah? It's okay? Nice. Hello, Internet. We are recording the session. We are gonna probably, we are not streaming it right now. Oh, yes, we are streaming. We're streaming. Hello, mommy! Okay, so I normally do these type of things to break the ice, etc. How many of you, I always share the same presentation. I would like to skip it at some point. So I would like to say, raise your hand for the people that is the first time that are coming for the BarcelonaJUG events. That is, I don't know, people that are coming brand new for the first time. So 4, 5 people already, okay. So I have to repeat the session every single day. At some point I will remind it in my mind, but yeah. So this is the BarcelonaJUG user group. We are a bunch of people that are interested in around technology. We do events like those ones. We share knowledge, we pair with others, we try technology, we sit down with a lot of things, and we try to gather people focused on technology. And you can imagine whatever type of tech event that you can do, and we did that. We have been done a lot of things. But we are also a non-profit organization like since 10 years ago, which is something that we are really proud of. And yeah, we did panels talking about technology, talking about careers. We did a lot of things with different companies, products, solutions, etc. And we have today another kind of event. Probably many of you arrived because of Meetup. Yes, yeah. But yeah, we have some of our sessions already recorded in YouTube. We have Flickr with some pictures of the events that we did, including conferences. And we have Twitter. If you have Twitter, it's free. You can tweet, and we will receive the notifications, and we can reply, etc. We have LinkedIn, where we normally try to announce the events, etc. And we have the website that is, I think, is really old, and we have to find somebody who can help us improving it. So yeah, a lot of technologies, a lot of topics we cover, and more that will come. And probably we have to update the logos, etc., because there are many things, I would say, a bit old. But yeah, we did a lot of things. I have also to say that thank you very much for all the people that are involved in here, including Dynatrace, who is providing the space, the location. Is going to help us to do the networking thing, the drinks, etc. And also Apiumhub to be our media sponsor. And as well, JetBrains. JetBrains is giving us some free licenses. So any of you needs an IntelliJ license, raise your hand later on, or come to us. Okay, come later and then ping us, and we will give you a license for you. Yeah, what else? I don't know. Yeah, we normally say that this is about doing efforts for the community, and it's about contributing, about giving your time for doing something. If you have any stupid, crazy idea about anything, raise your hand, send us an email, say, look, this is what we are doing in our company. What if we do something related to whatever, name it, I don't know. We are an online retail of whatever, and we are doing this weird thing with this framework. Let's talk about it. Let's see if we can do something, I don't know. We have been doing a lot of things like this. So we have also a Slack where we post things and we announce things, but it's not really reactive. So if you want to contribute and you want to share your latest article, go there and share it. And yeah, I don't want to spend more time. For the people that pay €2 for coming, we always explain that. We are gonna later on refund your money. We don't want these €2. It's basically that for people that would like to come and then later on do not join us. And we have this paper I have already here. Just let us know later and you write your name and then we will refund your money. And then you can also do some comments about if you like the session, if you don't like it, or if you want to receive some news about the company, you are interested in something, there is also a column for that if you want. It's an opportunity also to write, hey, I don't want to receive any information, or I want to, and I'm interested on something. Just write your email then later on. Yeah, I think so. We are done. Thank you, everybody, for coming, and I think now it's time for Sven, Severn, sorry. I'm terrible with the names, and he will start explaining about asynchronous Kotlin, and after his speech, we are going to have a 5-minute break where you can go to the toilet, etc., grab some pizza, drink, etc., and give a rest and something, yeah? Okay, welcome.
So first off, I'll start off with the kind of the anecdote. He had asked me how to pronounce my name, and that's something that comes around. The right way of saying it is Severn, but I told him, don't worry, because my grandmother couldn't even pronounce my name. So let's start with this. This is a presentation about asynchronous Kotlin. I'm glad to see all the people here. If you're here for this presentation, if you're here for Christian's presentation afterwards, or if you're here because you want to be in the glorious tower for the first time in your life, that's certainly not me. Anyway, there's going to be a lot of different code demonstrations, so I should get through. And also, just a general thing for myself, I like to put up a lot of links, so if you want, make sure you have your camera ready to take pictures of the screen frequently, very early, and very often. So, first off, let's start with old stuff, with the JVM and asynchronous. And let's go all the way to the beginning. The beginning with multi-threading with computer science really came about in the 1950s with something we called temporal multi-threading, back when the industry was really just very much in its infancy. But this one had a restriction that there was only one set of instructions that could come in to the thread to the CPU cycle every thread. So really, the type that we know about, where multiple instructions can come into the CPU at any given cycle, was debuted really with IBM, the ACS360 supercomputer. And that came out in the 1960s, and that's really what we know about today. And so a little trivia with this is that debuted in the 1960s, but it only really came to personal computing in the 35 years later or so, and that was Intel with the Pentium 4 processor and its so-called hyper-thread technology. So that little history lesson out of the way, we can get to Java. And Java has had threads ever since the first version of it, the first production version, came out in 1995. So obviously that allows for asynchronous programming within JVM. It came with a couple of costs. First, these are based on operating system threads. So they're pretty heavy. If you ever heard that, that's what it usually refers to, that it has something to do with the way that the computer mounts threads. And if you have too many of them, then you're going to get some issues with something called context switching, where it has to go from one thread to another, to another, to another. That has a cost, and if you start throwing up a lot of threads, that adds up. The next part is that these take up a lot of memory. And so if you run a lot of them and you don't have a powerful enough computer, you'll get an out-of-memory error, and likely that means there goes your program. I'll give a demonstration of just how fast or how slow it could take. First, I have this program, and the obligatory, can everybody in the back read this? No. No? All right, I'll make it bigger. Size 22? Yes. All right, great. So this one is going to run, I have it here, it's just so you know, 1 million threads. Run it, sleep for about a second, or sorry, sleep for 100 milliseconds. So I'm going to run this, and let's see if this thing, let's see how long it takes if it doesn't die. This is a pretty strong computer, so I don't think it's going to get a out of memory exception. With this, one more thing that I need to talk about, and that this kind of stuff with asynchronous, especially in Java, it is concurrency, is not parallelism. So you might be asking me, what's the difference between the two? Well, I'm glad you asked. Basically, the two terms are kind of used interchangeably nowadays, but there really is a difference. And so the first one is parallelism, which is everything is done, as the name implies, everything's done in parallel. You can see with the graphic here that you have one task that's being done exclusively on one CPU, and another task is being done exclusively on the other CPU. By definition, that means that you have to have multiple executors. So multiple cores, multiple CPUs, whatever it may be. And this basically is the architecture for things like the MapReduce or fork join that you see in Hadoop or CouchDB. Concurrent programming, on the other hand, is that multiple processes are done in the same time span. So what that means is that you can have this graphic where the tasks can get stopped, moved to another CPU, resumed, so on. The only thing that's important here is that these two tasks are done in the same time span from beginning to end. So a benefit of this is that actually you don't need multiple executors. You can really do this with just one. So we could rearrange this graphic so that it just has one CPU and it would still be concurrent programming. Now, this is a very, very basic overview of this. And if you'd like to know more about it, I've got this link here to Beldung's presentation or webpage about the topic a bit more in detail. So in general, the question for JVM developers became how to get better performance with asynchronous programming. And then we had a reaction, which came in the form of reactionary programming. Reactive programming, sorry. Reactive programming kind of turns the paradigm. It's a different paradigm that turns it kind of on its head. What you're doing there is you're creating a set of stages that react to how the data changes. Do X when you have object A, then do Y when A turns into B, then do Z when B turns into C, and so on. So, like I said, just based on observations on the change of data. And this came about, and this was really introduced into programming world in general by Microsoft's reactive libraries in 2014. And for the JDK, that was with Apache. Sorry, not Apache, Netflix, with the RxJ library in 2014. And this works a lot like the Node.js, the V8 loop. It's an engine loop. It's one thread that's going around, and it's getting a queue of small tasks, and I'll get back to that part later. There's not just that, there's also features that you can do for splitting up pipelines or dealing with pipelines that have too much data that comes in at a certain point and causing a traffic jam, as so to say, back pressure. Now, this did win popularity, but then we see this with Spring.io, with Netty.io, and Webflux. We did have some issues with it. And that was why it is probably not as popular nowadays as it was back then. First is that, well, the first one is, I'll just put all three of these up. So first is that there's compatibility. Everything is this one self-contained pipeline. And if you're trying to put that into your old imperative programming flow, there's going to be some issues with it. It's basically everything goes in it, or you're going to have to deal with jumping in and out of that, which can be pretty difficult. Another part is that I said small processes. So if you have a large process. This is the same issue that you'd have in Node.js. If you have a process that takes a long amount of time, you could get a traffic jam there as well. And you might say, well, don't make your processes long-winded, but sometimes that's easier said than done. And then you have stuff like the long I/O. If you have long I/O waits, that could really cause some issues for performance. And that is that was the reasoning behind getting the R2DBC library that came out for doing this reactive database interactions with relational databases. The other part is that debugging, error handling, they can be a bit complex. It's not the same way that you would do it in a traditional Java program. So first you have the debugging breakpoints. You don't do that. You have side effect stages. You say, all right, put this there, print it out, whatever, and then you can do the debugging there. The other part is the try catch and error handling. You're not supposed to do try catch. You're supposed to do this on error complete. And I can give a demonstration here. So I've got a program here that what it does is prints out the first 100 numbers that are not multiples of 5. But if we have 118, then it throws an exception. So right now I have this this one here. This up here is a comparison with Kotlin's sequences. So I'll run this. And everything runs fine. We get this running, and we stop here when we got to 118. All fine. So the question is, what happens if I move this exception situation out of there and into for each? I'll run it again. And now I have this exception. So I'll try to put on error complete here. I can't. It's on error complete is for a intermediate stage. It's not for a terminal stage. So that means I have to go back to try catch all the same. And the other part is I'll get this bigger and I'll show you. That is one big call stack. Compare it up to here for the sequence that I ran for Kotlin. It's a lot smaller. And this is really not a big, this is not a big call chain at all. So this is not just an issue of I've got a long exception that I've got to dive through. That has costs. Generating that stack, this call stack here has costs. And if you have a lot of exceptions, that the performance cost is going to add up. So we'll go to the way that Kotlin manages with code routines. So this one was released with Kotlin 1.3 back in 2018. We're currently at version 1.6.4. They are going to get version 1.7 at some point soon. They released the release candidates version this week, I believe. So this one works a bit like threads do. And it's just a basic overview for it, that you have a context, you launch the coroutines in this context, and if you have any threads, if you have any functions that are supposed to run only within those coroutines, you add the suspend keyword, which is function coloring. So aside from those two different parts about context and function coloring, the workflow is pretty similar. The difference here is that there's not as heavy as threads. If you've ever seen them, you can see that there's a lot of times where you'll see the different coroutines running on the same thread. And so that means you could launch 1,000 coroutines or 1,000,000 coroutines, and you wouldn't get anywhere near as performance issues or memory issues as before. So how do they do this? The short of it is that the code for coroutines is actually syntactic sugar for something called a continuation. And here's a bit more about what that is. But the short of it is that the code is actually broken down into different stages. And there are different points where the code can be stopped, either a delay call in coroutine or a call to a suspend function, whatever it may be. And then, so this state machine that gets installed in the program then determines when this code can be continued. And I will show you some code here that is the same as is the same as the thread type, this code up here that I showed in the beginning. One, it's going to run a lot faster. So it was able to execute in 4 seconds. And I'm going to now take a look at the, I think I need to do the, all right. Well, unfortunately, this one's the first glitch here, is that it's not showing the, it's not showing this. At some point, if you want to take a look at the Kotlin bytecode, this part here of showing Kotlin bytecode, it's really addictive to take a look at just what the Kotlin compiler does. What you'll see when you get that is this big state machine that runs all of this, that just sets up this breakpoint for here, then a breakpoint for here, then a breakpoint for here, and so on. So this did win a lot of popularity when it got introduced. Enough so that it quickly became a candidate for release, replacing Webflux. So it's basically a 3-step process for it, aside from changing the code out for the pipelines that you might have. First up, you add this dependency as a runtime dependency. Then for any functions that return mono, you just return a normal object, or you have a function that's colored with suspend. And then if you have a flux, you do the flow class instead of the flux class. So that's all the old stuff that I presume that everybody knows. And so let's go on to something that came up last year. At the end of last year, JDK 19 was published, and that brought about probably one of the biggest projects that everybody's been looking forward to, Project Loom. So version 19 of the JDK released the first public version, not production version. That's coming in, I believe, in 21 of the Project Loom, which you can go into more detail about it in this blog post here. The idea of it is that these are lightweight threads. They're no longer the heavyweight operating system threads that you have before. But unlike Kotlin's coroutines, there's no difference in the workflow. There's almost no difference in the workflow compared to coroutines. You just launch a thread the same way that you would launch the normal threads, the old threads as before, and that's it. So now you really get the idea that you could launch a lot of threads, thousands of threads, or even millions of threads if you really wanted to. But there is one thing that you have to use for now. You have to use the unbounded executor. You cannot use a bounded, you can't use a thread pool, basically. Because I have the, I can go here to take a look at the Loom type. So it's simply saying start a virtual thread, which is this new virtual thread. And then I think, so if you try digging down into it enough, you can see there it's package protected. You can't do it. Same thing goes for the executor service that they have for the virtual thread pools. So maybe they're going to change it in a different version. Maybe this is just the design, how it's going to be. We'll see. So right now it's just a preview version. So really, you can play around with it. You can try seeing how good it adds to your capacity in your programs. But just you have to make sure you enable the experimental features Plus, there's all the caveat emptors of this functionality might change in the future. There might be bugs that can blow up your program, so on and so forth. Still, it's a nice first step. What this did, though, when they announced this, and further and further, closer and closer to its production or it coming out as a public available version, this raised a question. Are we seeing the beginning of the end of Kotlin's coroutines? Because, well, the main selling point for coroutines is launching lots of processes at once, not having to worry about the native threads. And if that can be done in virtual threads, plus you don't have all those restrictions of context and colored functions, well, are we going to need Kotlin's coroutines anymore? The answer is that, well, this is probably not going to be going away. Here are a couple of blog posts, discussions on Kotlin's forums, and a different article about it that goes into detail. There's a couple of things. One is that Kotlin's coroutines are multi-platform, the same way as Kotlin is. So that means that you can have this coroutines for JVM, you can have it for native, you can have it for JavaScript, whereas the virtual threads are only going to be on Java's environment. The next part is that these two different libraries are kind of different in terms of what they want to do. So virtual threads are more designed to just improve the way that asynchronous code gets executed. Just make it a lot faster, because Java has had this issue in the past. Coroutines are designed to improve how we write asynchronous code. Because it's not just Kotlin coroutines and lots of processes. It's also the idea that you can have these things like the flow, or you can have channels, a lot more different tools than just the coroutines themselves. Still, it's probable that we're not going to see one library beating out another. We're probably going to see collaboration between them. It's easy to see that the authors of the Kotlin coroutines could be introducing some of this virtual thread code into their own library in the future. We can actually do it ourselves right now. How many people have created a special executor, like a thread pool, for your coroutines in your code? Anybody? Well, okay. First time for everything. Basically, the workflow is you create an executor, and then you run this extension function as coroutine dispatcher. Now, I have this attached to this virtual thread per task executor. This is the executor for virtual threads. It's unbounded, but for us, not really going to make much of a difference. The important thing is that we can now actually integrate this into coroutines and have a kind of a hybrid strategy. So I can run it. And it's going to give me pretty similar performance. Again, ran 1 million threads or 1 million processes, and it's ended in about 4 seconds or so. So I actually did some benchmarking of this. I did some analysis on this a couple months ago, and bit more into how fast these things run, memory things. So if you want to take a look, that's up on our blog, and you can take a look later. We're down 2 sections. We're up to the last one, the things that I presume many of you haven't used or even heard about. First up is atomic operations. Now, I presume that most people have used atomic integers, atomic booleans.
The screen
Yes.
Yes. Hopefully it's not too much for the screen.
So anybody wants to just stretch and just get a little bit of motion? Okay. Atomic operations. So people, I assume that everybody's used atomics from Java's libraries before, atomic flags, atomic Boolean, integers, and we have atomic FU, the way of doing this in Kotlin. So FU stands for field updater, so it's likely there's a field updater class in Java, the JDK, so I assume that's a reference to that. So what this library is about is that, one, like the rest of Kotlin, it's multi-platform. So you have atomic operations that you can do not just in your Java code, but also in your JavaScript code, your iOS code, and so on. The second part is that it uses the operator functions. So it gives you this neat little trick where you can increment, for example, an integer using normal mathematical operations, but keep it as a val. And you don't have to worry about calling some long-winded function name, which really isn't as intuitive as just saying plus. I can give a demonstration here with this code has 10,000 processes that it's going to run, and it's going to so it's going to increment both save counter and unsave counter. So I run it. You can imagine what's going to happen to unsave counter. It doesn't reach 10,000. The save counter does. But you can see here that the way of incrementing was exactly the same between the two, even though this was a val. Theoretically, it shouldn't happen with normal code, but this is what the library does. Another part is the running it in JavaScript, and it's mostly the same. The difference is just how it gets compiled to code, and better to just go through here. It doesn't really do much in it doesn't actually do much in JavaScript code because JavaScript is single-threaded, but still, it's good to have this kind of continuity between your different code platforms. Wrong one. So a couple of restrictions. The first was that they said that it needs to be a val. It cannot be a variable, and it needs to be a class level function, or it needs to be an attribute of a class. It can also be file level because that gets compiled, that gets wrapped in its own class by the Kotlin compiler. So theoretically, I shouldn't be able to do this. Oops, I'm in the wrong class here. Okay, they did fix that one. I was going to say there is one of the issues that this is still in a bit of a rough state. So there's issues with IDE, and it's still in beta. The good news is that they are working on having this library stabilized by the end of the year. They announced it in the roadmap for 2023. And if you want to see it, in action, it's already being used in KOTOR and a couple of different places as well. So here is the library for it on GitHub. You can take a look at it if you have any thoughts about it, if you're just curious about seeing what it does. Next up, has anybody done testing for thread safety for their code? Anybody? Well, one would imagine that the way to do this is simply launch a lot of threads in a test case and see if everything comes out correctly. Now, there's other ways to do this, and here's one way to do this. which is called lincheck. Now this is a framework for doing this kind of thing within Java, within Kotlin. And what it does, it's a fuzzer. Basically, it runs a lot of scenarios, runs threads at a lot of different variations. And so it operates, the workflow is that you have a function, you have operator, you put that on there. That's going to be something that the threads are going to execute. Then you set up a verifier, you run a stress or model-based check, and that gets done in whatever test framework you have, like JUnit or Spock, whichever it may be. So here's a test that I have. This one's going to fail because, well, it's as the name implies, it does incrementations in an unsafe way. So I'll run it. I have two different options for running tests here. Now this one, it says we have an error. We have an exception. It said that it failed. Not really much you can see here. So here's when I try to run this using model. I'm going to get into this a little bit later, but there are two different ways of running this: stress and model-based checks. So you can see it runs a lot. It gives you a lot more details of what actually happened, what the race condition actually was. So the default is it has a default validator, and it goes for race conditions, deadlocks, and so on. And has two different types of testing. Basically, less details and less intensity, more details, more intensity, that kind of thing. But there is a lot of customization. I'm going to go through this a little quickly. First up, you can pass in JVM arguments. And this is actually something that you need to do if you're running anything past Java 8 and you have and you're using something from the Java util package. So basically, any lists, any maps, anything like that. This is going to fail right now. The only important thing is that you see the red, which I'll get back to that. Here you go. You can see there was red, basically. This failed on that. Now I have here, you have to have these things here, add opens and add exports. If I comment these out, and I'll run it again. Oops, I need to reload, sorry. And I'll comment that I have these other options here. So there's a lot more options that you can add. And these are things if you want to pass things straight to the JVM about working on different types of JVM configurations, not just the opening up packages. So now I'll run this one again. And this one should fail to even run. I think it might be slow because of a couple of different things running at the same time. All right, I'll get back to this. Another one is running parameterized tests. Oh, it did run, okay. Well, running parameterized tests, because in this test I have it generating different keys, different values. So there are things that are available by default, which is like the int gen, and you can put in configuration here, 1 to 100. So basically any number from 1 to 100 that gets passed in via parameters. You can also implement your own. It has to implement this parameter generator interface. Verifying, putting the verifier state and overriding extract state. This is just making sure that it's shutting up the test executor. For most tests, it's pretty simple. You get pretty simple tests. It's not going to matter much. It's just an issue of keeping a thing from putting up a lot of warnings. Another one is JC stress. There's a similar tool that exists in the JVM ecosystem. It's not one-to-one compatibility with functionality, but you can get pretty close. And this is by having a validate function, which one is it? Yeah. So this one I have here. You can have a validate function, which then you can run the check function from the inline check function with Kotlin, and then you can implement your own verification to see like, all right, it shouldn't equal this state. Not whether or not there was a race condition, but whether you have your own verification. So when you do this, it allows you to reproduce some tests from one of my favorite articles. Alexei Shepardov wrote this in 2016. This article about the JVM, the memory model, and the ways that it can really burn you if you're not careful with your asynchronous programming. Highly recommend you go to his website if you're interested in any kind of in the weeds discussions about how the JVM works, this memory model, optimizations, and so on and so forth. So there's even a lot more than just that. They already have a documentation guide for lincheck that you can go on and read through and see how you could implement this in your own projects, however you'd like. So I want to wrap up and say that I started coding about 17 years ago when I started with university. And Java back then was JDK 6. Progress on it was seemingly glacial, and there were no shortages, for example, of Java is dead articles like a decade ago, that it just seemed like it was going nowhere. So really, I'm amazed at how much has improved over the past 10 years. We've gotten the reactive libraries, we've gotten JVM JDK 8 with streams and Lambda, we've gotten Kotlin, the coroutines, and now we have some stuff that's even coming over the horizon. Loom is coming over the horizon. These tools that I mentioned in Kotlin, they're working on those. So there's a lot that can be used to help with your code, but they're still tools. And tools, in the end, well, a 10-euro hammer isn't as good as a 70-euro hammer, but a 70-euro hammer will not prevent me from busting my thumb. I can still hurt myself really bad if I'm not careful. And that's the same kind of thing that we need to do. You don't want to have some picture like this showing up in your head if you have a code issue. So now we've got tools like JC Stress, the new one like lincheck, these other tools here that really should help us improve with asynchronous programming in the future. And I'm really excited to see what the next 10 years are going to look like for the JDK. So, are there any questions? All right, well, thank you.
All right, so there are hundreds or probably thousands of tools and frameworks for testing. You may recognize some of the ones that I just added on this slide, maybe, I don't know, Selenium, JUnit, Cucumber, gbehave, I don't know. There are many of them. And I'm sure we would never agree on which one is the best for any purpose, because all of them have a different set of features and all of them cover different kinds and types of software testing. So my talk here today is not trying to solve this and trying to come up with a solution that nobody knows. It's just to try to make you understand that there is a way for all of us to give something to the rest of the community and try to just benefit from the most important things that each of these tools can give to us. So my name is Cristián. I work as a software engineer here in Dynatrace. Previously to that, I was working on the Barcelona Supercomputing Center, mostly focused on research for distributed systems. And here at Dynatrace, I'm involved in processing and aggregating session data for real user monitoring and developing the next generation of behavioral analytics database and storage. So today what I would like to do with all of you is some kind of experiment. So I would like to try to define a common ground where all of we kind of agree on what is the purpose of some kind of testing tool or testing framework. So let's try to start with something really basic. That is, do we agree we could divide testing between functional testing and non-functional testing? That is, let's say we try to check that the software does what it's supposed to be doing. And on the other hand, we try to check that it does it in a certain, let's say, time or performance reason or security constraints or whatever. It's not really non-functional, let's say. So at this point, I would say mostly everybody in the room could agree to that, isn't it? If I try to twist this a little bit more and say, can we try to agree on something more? So could we try to divide this in several sections? So what if we say functional testing could be divided in unit testing? That sounds like fun. Integration testing. Then we move to system testing. And in here we would say, all right, this could somehow involve end-to-end testing, which might be related to integration testing at some point. But let's say it could be different. So let me keep those families separated. But in here, I already know that some of you might not agree at all. So, and we can also have acceptance testing. But when I talk about acceptance testing, I would say, do we define acceptance testing only for functional testing? Should we take care of non-functional things when we do acceptance testing? So I'm already putting here a family that some of you may not feel really comfortable with, because you will say, this family should be maybe between these two kinds of, let's say, big families. Just for the purpose of continuing with the talk, let's keep it here, okay? I will come back to this at some point. And I move to the non-functional testing. So let's say I also define 4 families, just to be fair, between the 4 of them. So I have security testing, like if the test is vulnerable to any data breaches or malicious software or whatever. Some performance testing, that is, I don't know, doing load testing, trying to check where are the limits of our system, how does it behave under high load, and all this kind of stuff. Then I can move to usability testing. So is it easy to use for the users? Do they feel comfortable using our software? Should we do something different when they move from one platform to another? And then I can relate this part to compatibility testing. So does our software behave the same way and on a similar fashion when we move from one platform to the other? Does it provide the same experience to all the users, even if they are using, I don't know, Chrome or Edge or Safari or whatever? So when I try to define this new set of families, there are already some kind of questions that can appear where we could all argue whether this should be the actual classification or not. So as I said, system testing doesn't feel, or acceptance testing doesn't feel like they should be only functional. We could talk also about regression testing. What happens to it? Should it be a new family? Should we include it inside system testing? Because it always takes the consideration the whole system. Or what about localization testing? So whether people around the globe experience the same way our application, despite of the language, despite of the place on the world where they open the application. Or maybe accessibility testing. So Do people with disabilities have the same experience even when using screen keyboards and other stuff with our applications? Do they interact in the same way? Should we be testing that? Should we be doing that? So there are many questions that here can come up, and I'm sure we could spend like 1,000 hours trying to discuss them, and we won't ever agree on something, because in the end, each of us value a different thing, and each software has different requirements that need to be understood specifically. If I try to twist this a little bit more, I could say that I could bring up to the table many, many small families inside those families. So I could try to divide these in, I don't know, I put here lots of them. So white box testing, maybe end-to-end testing, or monkey testing, or alpha and beta testing. And you could also argue, should we keep them on these parts as I classified them, because that was a choice, to be honest, or should it be moved to another section? And if we start this conversation, we will start moving things, if they move, yeah. So we could start moving things from one family to another, maybe starting adding the regression testing, or maybe defining some business and user acceptance testing also to the family. And maybe should we move the acceptance testing, as I said, to the non-functional one, because we now realized that doesn't make sense. Or maybe we could include exploratory testing inside the black box testing, because actually it's a subfamily of it. It's just another way of testing usability. Or maybe we could do use case testing, and where does that use case testing fit? Because that's a kind of end-to-end per business unit thing to test. Or maybe we should say, all right, so it has gotten some momentum. We always talk about behavioral testing, so where's behavioral testing? Where should we put them? And if I start like this, we just drive crazy and everything explodes, right? So there's no way we will end up with a solution that all of us agree and has a classification that makes sense for all of us. Because when you talk about testing, somehow you're talking about how your software feels and how your software wants to get delivered to the user, which surely is not my software. So I would never, or mostly never, share the same feelings and the same idea that you have about that testing. So my idea, or my proposal here, or my take for this talk for all of you would be try to be more open-minded. So stop classifying your tests for your software. Stop trying to decide which type of test you want to build, and instead try to contextualize it to define which purpose do you have for that test and for that software, and just choose the easiest and most simple way to do it. If that means building your own solution, twisting the things you have or the tools you have on your framework, let's say on your company, to do that, just do so. Because making this more complex because of fitting to a certain name of testing and way of doing that testing is just going to make things more complicated. And I would say that for software, the first thing we need to take care is to keep it as simple as possible. Otherwise, it just gets super hard to maintain. And related to maintenance, another thing that we should stop doing is to stop sticking to only use one kind of test. Not just one model, but just one framework. Be open to try to do anything. Just consider the cost of maintaining it, the cost of adding it, and if your company or you feel like that cost is well enough surpassed by the solution that it gives you, the security that the software you're delivering is secure or is stable, then just do it, just put it. All right? In that sense, I also have the feeling that most of the times when we talk in our companies, there is a first rejection of a new proposal. So when we come up to an architect or with someone who has more seniority than us with a new testing framework or with a new solution, we do see how we could benefit from that. But they normally reject the proposal because it feels like we're adding another library on the 2,000 libraries we already have that will not provide us with anything new. So my point here would be always try to listen to people that are bringing new software and new testing tools to your company. Try to not just listen, but understand what they are telling, what are the benefits of it, and then go back to the first point and try to analyze the effort of building and maintaining that tool in your stack again. Because if that effort is not that huge, maybe including that library in the first place is going to solve you 10,000 hours of bug solving in 1 month. So then that's worth it. And again, this can be related to collaboration. So try to build your software and your testing on a way that it's reusable for others. So if you're benefiting from a library, just don't stick to using it. Try to get other people on your same company or maybe on the same collaboration zone to do it, to try it, to just see what you have done with it. And maybe they will try it on their projects, and maybe they will bring you new solutions or new ideas to benefit from other frameworks or from other testing ways of doing things. And finally, there's something that I would say it's a little bit cumbersome, but I have the feeling that there is a goal that has always been there to have 100% test coverage. And I do agree that might be useful as a goal, but that's not useful if you just pretend to always try to get that 100% goal. Why? Because when you try that, you just close your doors to collaborate with others and to try other things. Because you just want to have 100% of the lines tested, instead of trying to have all your business cases tested, or all your real-world cases tested, whatever you want to call them. But there are many things that might not be needed to be tested, and there are many things that will only make things more complex because we just want to test them. So my point here would be, don't try to stick to that. Be a little bit more flexible. Leave room for incompleteness, leave room for things to be improved in the future, so that you will be able and open to try other frameworks to just make that room a little bit smaller. That being said, does that mean that testing should be chaotic? Not at all. So I'm not saying that. I'm not saying that you should all just erase your ways of doing testing and just come up with whatever test you feel. I do think that we all work in teams, so we can come up with agreements, we can come up with some common sense when talking to us, and try to find a way to just have the things sorted out on a way that we all understand what's the purpose of that test, and why we want to have that test on our software, and what's the benefit of having it. Another main question would be, does that mean that companies should be open to testing any framework? So this is not, obviously, there are not brands of testing. It's just a picture taken from the internet. But the thing is, a company cannot maintain something like this. It's impossible to have a company maintaining 2,000 different tools for the same project because it just doesn't scale. So it's obvious that at some point we need to agree on which ones we will be using. And that's where communication comes up again. You need to be able to talk to the organization and to decide whether we could include a new tool in favor of another one. Or should we be upgrading from one version to another one because I can then include some kind of regression testing or whatever kind of other testing you're trying. And another question that mainly comes from developers, I would say, does that mean that I will need to have 10,000 meetings a day to explain people why the fuck did I test on that test? Not at all. Tests should be self-explanatory. You should have documentation maybe, you should have team agreements, you should have a clear way to asynchronously communicate the purpose of having a test. That doesn't mean you need to have 10,000 meetings a day, which we all try to avoid, I'm sure here. But my point would be, if you build them on such a way, in such a context that everybody tries to just understand what you're trying with that test, not what type of test you're trying to build, just what's the purpose of it. I don't care whether it's use case or it's end-to-end. I just want to know, what do you get from that test? Is it simple enough for others to understand? Then let's move on. If any of those questions cannot be answered that way, You might have a meeting, for sure, and maybe you should ask yourself, did I define the tests as I should? Because this triggered a meeting, so something is wrong with them. That being said, oh, that's the no, I missed that. That being said, I wanted to also enforce a little bit this philosophy with something that happened on our team on the past, I would say, 2 years. So just to give you a little bit of context, it's a simplified version of what we do here in Dynatrace. So on the one hand, we have some set of events that go through some kind of event processing or whatever you can imagine here, right, as a system queue or whatever. I don't really care. And at some point, you have a service which is stateful. So the important thing here would be this has a state, all right, and does some processing over these events to build what we call sessions, all right? So a session would be, in general terms, an aggregation of events that define a certain set of actions in a web page, for instance, or something like this. And in the very end, what we want to do with those sessions is just store them in a database, whatever database you can imagine. I don't really care about the technologies here. So when we first started with this project, we had a testing framework, let's say, more or less similar to this. So again, this is a little bit simplified, but on the left side of this purple area, you can see our domain. So the domain that we had was an event coming to our system and a session being the aggregate of those events. We defined some unit tests. We also defined some integration tests. And we also defined some system and acceptance tests. And in here, we could also argue whether they were acceptance or not, because many of the non-functional requirements were not really tested in this part. But some of them, like the performance that we had, were tested on this part. So what happened? We had many different folders. We had more than 1,000 tests in 2 files. So you can imagine those 2 files were just simply something we couldn't maintain. And when we tried to check whether a functionality of the software was tested or not, there wasn't a clear way to do it, because we had several functions and several things tested as unit tests, and we had the whole system tested here. But it was very difficult to analyze whether certain parts of the testing were being actually tested or not. So that ended up with having bugs on production that we thought we were covering, and we weren't covered. And somehow this was triggered, again, by having a 100% coverage over all our code base. Because as you can see, with this description of the testing framework, you can cover whatever you want. That doesn't mean you are covering the feature set or the use cases you are providing to your users. So we did the first iteration over it. So the first iteration was to kind of split a little bit more the domain. Pizzas are coming. So I will be fast here. So the idea was to have, again, the event definition and the session definition in the most possible anemic way, so that they are just containers of information. And then we had to create, for sure, some services and some use cases to represent our system. So we were having events coming to our system, and we were storing services, sessions, at some point to the database. So these services were trying to divide those 2 responsibilities. And the session store use case was just trying to englobe the whole use case of our application here. So at this point, we decided to get rid of the integration tests, because that were run only during the merge of the PRs, and we weren't having the actual information during the development. So we decided to get rid of them. And we also moved the big part of them to the actual integration tests. And we came up with different files to try to solve having everything on one side and try to divide the responsibilities. What's the problem of this? An event service test can test as a black box, let's say, everything that happens here, but does not test anything that actually is the user doing or interacting with our system. So when you have a problem because somebody didn't saw the regular information on a session, you cannot say that you have a test to try it out, because you only have tests for certain parts of the service. And the second big issue we had is that in these tests, we mocked several things that maybe we shouldn't be mocking. Because when you're developing tests in a separate way and you're developing a new feature, for instance, inside this service, you tend to mock everything else, because what you want to try to test is the new code you're adding. So you say, I'm not going to build a huge test just because I added 3 lines here, so I'm going to mock the rest of the world and I'm going to come up with a test for my own solution. And that ends up with services that work perfectly alone, but cannot work together. And as they cannot work together, we came up with some system tests or end-to-end tests or whatever you want to call them to try, I don't know, single event sessions or multiple event sessions or per event type kind of sessions. And those tests were just simply huge tests that were not maintainable, because you need to create the whole system just to test something that might be done in another way. And at this point, we also created some code agreements. So it's the first time we realized things were a bit messy, and we could benefit from having code agreements instead of trying to have just one way to do things. So we tried to be a little bit more open, all right? And with this second version, so first iteration, we came up with a second iteration, which is already the third version, and we tried to simplify this a little bit and use more common sense. So in that point, the code agreements were much bigger than before. The domain model was a little bit different, all right? So we tried and we allowed to enrich a little bit more our domain so that we could have tests on these classes that could only affect to certain functionalities of the session or the event. Is that a unit test? I'm sure that's a unit test. The thing is, we weren't focusing on having this tested on a full use case, because that means building something very, very big to test something very, very small. So we wanted to allow this kind of testing. And on the other hand, we also had the event service, the session service, and then 2 different use cases, one for adding the events, one for storing them. And we tried to focus on, we want to test whatever our users do. And at this point, for us, the better solution was to focus on use case testing. So we tried to define anything that our application wants to do, and we tried to test it in every way possible. So whenever it fails, whenever everything goes fine, etc., etc. Doing so, we also allowed ourselves to have better communication with our stakeholders. Why? Because when you are defining a test of how the users will interact with your system, it's easier to talk with a PM and understand with him what are the requirements that need to be met. Because in the end, you are just defining them and putting them into code. But you can agree with him or her, how do you want to build your software in that way? And I know it's a very simplified version, but that's kind of how it looks now today. We do have on these very lots of tests, some use case tests, we have integration tests, we have some security issues, and we have also moved to include many other frameworks or testing frameworks to try to make this easier for us. So I would say that if you have some takeaway from my talk here today, it would be, please talk to your peers and use common sense when developing software, but also when testing that software. Because trying to come up with complex solutions and sticking and discussing over one name of how we try to test our software won't bring any value to you. Trying to make things simple so that anybody in the world can understand your software and feel comfortable developing on it, it's going to bring and be 10 times better than all those discussions together. And I would say that's all from my side. I know pizzas will be coming, so I won't be in the middle. If you have Any questions, or do you want to ask me something? I will be around. If you want to do it now, you can do it now too. Go ahead.
I have some questions related on how you, let's say, visualize, right? The amount of things that you have on the right-hand side, or how you, let's say, identify that you are missing some tests on the integration side, for example, some security tests or some use cases, no? Do you have any kind of mental process or mechanism to understand? Now we have to figure it out that on the integration side we have to build something new that we forgot, for example. Or how you normally do the workflow around it?
I can say how I would like to have the workflow, and then I can tell you the truth. So, on our case, we are much focused on use case testing. So we try to define the use case that we're going to cover. Then I'm going to tell you the reality, and then we will go back on how this should be. We define the whole use case. Once we have the use case, we define a happy path test. And then we try to go over the code to see where things could go wrong and try to include all those tests. So if I had to say, we are doing all the way around. So if we were following something more related to TDD, for instance, we should be defining the use case test, the actual happy path of what we're expecting, and then try to define what can happen to our system. And then let's build the logic. But that's something we're not doing, to be honest. I can value that. It's something I have been trying for a while, but I'm not getting used to it. But yeah.
I can find similar analogies. What we are doing right now, we call instead of use case, well, we have use cases, but we name it like acceptance test.
I don't care about the name.
Yeah,
that's the thing.
Yeah, and then later on we have been introducing this into the system, let's say, and then we start building integration tests and then unit tests, etc., and then also performance tests. But yeah, more or less I can feel.
So the thing is, when you call it an acceptance test, it should only take care of the input and the output, which means you are very restricted when doing such a test, because you can, theoretically, you cannot know the behavior of your system, because that should be a black box. We, on the use case test, allow ourselves to know what's happening under the hood.
So you understand everything that goes from the outside, let's say, until...
Yeah. So if I need to build an end-to-end test or a use case test where I do know that I will have a failure on accessing the database because I know how my system is built, I will build it anyway. Because I find it easier to have on a single file all the things that can go wrong when trying to process an event. So for me and for us, for the team, it was easier this way, to just not stick and say, all right, acceptance test on this side, so let's just check input and output. And then if I need a different service and to check whether it is fault tolerant or can access or can not access the database and it raises the correct exceptions, let's have it on another file, maybe with another test. Then for me, the thing is, you haven't tested the interaction of these failures with the actual complete acceptance test. But in the acceptance test, you will then build another test which fails or works or handles that failure when that simple system has raised an exception. So we try to merge both things and have just one test, just to keep it simple. It has also a drawback, you can see it. So you have much bigger tests that all look kind of the same way, but are super big. So you can have a file where one test have 1,000 lines and everything's there, and you just want to test that a database is failing. But since all the tests are built the same way, we felt more confident with it. Maybe for the next iteration, we'll try something different.
I expect that iteration.
Yeah.
And the last question for me is how QA affects or is introduced or is related with your work?
So up to here, I haven't talked about QA.
Okay.
So for me, that was, let's say, something that we feel responsible for maintaining. And QA for me is another extra step.
because then we have another level of testing.
That's the thing. So normally you have them maybe in a separate repository, you have other people that take care of them, you also need to take care of business limitations, you need to care about user limitations, and I would say that's mostly focused on developing from our side rather than going up to QA. Yeah, a full end-to-end, like when you have everything deployed and everything, that's something that's out a little bit of the scope for me. Any other question? Yeah, go ahead.
Yeah. Applying this methodology against the first stages.
This one?
Yeah.
All right.
But the difference of times of compiling and applying testing increases or were the same, or what do you think?
Let me think about that. Because we had many issues with compile times, but that's nothing related to our team. So
Maybe is the testing time improved comparing between?
no, I won't say there was a difference on the testing compiling time. No, there was a difference on the coverage. So we started this with around 70 to 80% coverage, and now we are around the same numbers. The thing that has changed a lot is the time we spent trying to develop a new test. Because at some point where tests were divided like this, we were replicating tests in different parts of the code because we were not aware that the thing that we wanted was being tested somewhere else. And having a more cleared structure, let's say, where you can just test features, if the feature is tested or whatever the use case you have is tested, then it's tested. Otherwise it isn't, so the test is missing. And in this scenario, you can imagine that if you're receiving an event, this could be a simple function tested in the session test as a unit test with different events, malformed, right formed, or whatever. Or this could be tested on a single session test where you try it out. So for us, that was a big difference, let's say, on knowing what has been tested or not. And then second big difference, not about compile time, but maybe that's more related to Dynatrace. These tests, slow tests and big tests, are only executed by the Jenkins pipeline. They are not usually run by developers on their machines before opening a PR. So then you get a clear sense that you have some limitations here, because until you open the PR, you won't be knowing if you have broken something related to your integration tests or your system tests. And that feels weird, isn't it? Because you need to wait to open a PR to see that you broke something somewhere. That doesn't feel right. So when we moved to the use case, the first thing you saw is we have got rid of this layer here, and we have tried to move as much as possible from the big tests to the tests that are owned by us and that we can run on our machines, so that we can have maybe not an end-to-end test, but some use case test that we can run before even opening a PR, so we do not need to bother other people when our code is broken. Does that answer the question? Kinda?
Yeah, I just wanted to know, like, if there was a big improve or of time, but it was more of concept.
Yeah, not of time, I would say. I mean, time and coverage has been more or less the same during the whole development from the past 2 years. Any other question?
A short one.
Yeah.
So could you please provide, just to be on the same page, could you please provide your short definition of system test and acceptance test? And the question is, what do you think? Could system tests duplicate acceptance tests?
So for me, system tests would be to test the functionalities of the system. Acceptance test would be to test the user interactions with the system. Could that be that they are the same? Yes. Could that be that you can include acceptance tests within system tests? Yeah, I can feel it that way too. I do have some feelings that system tests should be more functional, and acceptance tests should be a little bit more non-functional. So you should be including whether your system reacts on 3 seconds. And I wouldn't expect to have a system test that just compares if you are reacting to something below 3 seconds.
Okay, thank you.
Yeah. Any other question? Then let's have some pizzas.